Now that you've had a chance to see the executor service in action in the context of the PrimeChecker app, let's go ahead and take a look at the pros and cons and evaluate what it is we've seen so far. And we'll use the PrimeChecker app as kind of a touchstone to make the discussions more tangible. But what I'm talking about here would be relevant to any other uses of executor service. So first, let's talk about the good stuff. So the executor service version of the PrimeChecker app fixes a bunch of problems with the earlier executor version of the PrimeChecker app. For example, having these two-way semantics of Java callables allows us to decouple anything related to the Android features in the Prime callable class. So there's no more activity stuff here. Whereas if you go back and take a look at the earlier version, there was a main activity field in each Prime runnable, which took up space and also was tightly coupling. And therefore, when runtime configuration changes occurred, our earlier app didn't handle those things gracefully in any way, shape, or form. The ability to interrupt stuff is another big feature where you click that button and it causes everything to start shutting down. We shut down the background threads, we shut down the worker threads in the executor service, we shut down the background thread, and so on. So all the running threads will then be told to go away. And of course, we wrote our code carefully to be responsive to that, and here's how we did that. We had the interrupted method check here in the isPrime loop, and if something went awry, we broke out. And you can see we check ourselves repeatedly to see if we've been interrupted. So that'll be very, very responsive. Now, the only downside with this is every time through this loop, we're checking to see if we've been interrupted, which could be, I won't say expensive, but if you didn't want to check every time, you might check every 10 times or something like that. So it'll still be responsive, but maybe not burn quite so much CPU time. Another nice thing here is that runtime configuration changes of the phone, rotating from landscape to portrait and so on, are handled gracefully. And what's cool about this, it's really cool actually, if you rotate the phone, the tasks keep running in the background, and once it reorients itself and a new activity is created, then what is displayed is just the results of those tasks that have been running in the background. So there's really no hiccup, there's no interruption, there's no variation. It just keeps running, and when you get done orienting the phone to the new configuration, voila, everything shows up that you've been doing. So that's pretty cool. But of course, not everything is unicorns and rainbows. There's also some limitations here. And one of the main limitations here is the fact that calling future get blocks this thread. Now keep in mind, it's a background thread, so it's not a problem that it's blocking. It's just that it's blocking on the order in which the tasks were submitted. Think about this for a second. This is really important to understand. It's kind of subtle, but let's say that we have a bunch of numbers we want to check to see whether they're prime. And as you can imagine, how long the computation takes to run depends on what the number is. So if the number is like an even number, that's going to be a really fast computation because you'll quickly discover it's divisible by 2. But if it's an odd number, or if it's a prime number, especially if it's a prime number, it's going to take a long time to figure out whether it's prime because it's got to go through that whole long computation in the brute force approach we looked at. So what happens here is the amount of time it takes to start getting responses back is determined by the order in which you submitted the random numbers. Some of those random numbers, if they were even or they were quick to figure out what their factors were, those things are going to come back right away. They'll be done. But this particular code won't realize that because it's waiting for the results in the order that they were submitted, not the order they finished. If you got them back in the order that they finished, you could get responses back much faster. So for example, let's say that just for bad luck, the very first item we submitted was a giant prime number, and then all the rest of them were not prime numbers. They were even numbers. So we won't, using this model here, we won't get back any results until that first big number finishes. And that could take a long time, even though the other ones have long since finished. It's kind of like when you go through a drive-through, and all you want to do is order like a Coke or a Diet Coke or whatever. And the person in front of you in line has got like a minivan full of soccer players who have very complicated orders. And you could get your order filled instantly, but you have to sit there waiting while they fill this other giant order from the minivan full of soccer players who want to want to get something complicated. I'm not picking on soccer players, just that's what you put in minivans these days. So bottom line is, if you could instead get the results as soon as they finish, some people would get their service a lot faster. But this model, the synchronous future processing model, waits in the order of submission, not the order of completion. That's the key distinction to remember. And yet another problem that was shared with the earlier executor implementation, we just haven't got around to fixing it yet, is that this brute force method always is used, even if we have computed the results for some randomly generated large prime number candidate earlier. So we may have already checked some big number, but because of the way we've done this code, it always does that computation over again. And we're going to fix that in the next section by using what's called a memoizer. And a memoizer is a very cool data structure that basically caches results. So that's the end of evaluating the pros and the cons of the Java Executor Service. Are there any questions about that? All righty.